Welcome, dear students. During this class, we will study about current and electricity, and in this chapter, we will go in detail what the electricity and current is. Current and electricity. So here our chapter starts, and starting from the first. That is, first we will follow some of the sequence to understand the topic clearly. First of all, let's make a question. Define the concept of steady current and define its unit of the current. So here is the definition. Definition is the rate of flow of electric charge through a cross-section area of a conductor is called electric current. So this is the definition. And following the same definition, if anyone asks you how will you represent, so this is the sign used to represent the current, and it is represented with I, and I shows basically current. This is I, which represents the current. So if you look at the mathematical formula which is used to calculate the current is charges flowing Q per unit time. That is basically the basic concept of the current. So here we have defined first, and then we are uh, converting it into a formula shape so that to calculate the amount of the current. So whenever you are asked to calculate the current through the conductor, at that time you will be given two types of the quantities. One is the charge, other one is the time. How much charges are flowing, how much time, during how much time. This is basically current. So here we have defined this quantity, that is rate of flow of the electric charge through a cross-sectional area of a conductor, that is called electric current. So this is the definition. So here is the formula. If you follow, then we are following to write down the unit of the current. Unit of the current is basically I, that is equal to Q divided by T, and it is basically its unit is ampere. This was the formula. 1 ampere means 1 coulomb charge. When 1 coulomb charge passes in how much time? During 1 second. If 1 coulomb charge flows in 1 second through area cross section of a conductor, then at that time the current passing through the conductor will be 1 ampere. So this is the unit of the current. So whatsoever the amount of charges are flowing, if the charges are flowing 1 coulomb charge during 1 second time, then the current passing through the conductor will be 1 ampere. So this is the concept of 1 ampere, and we will define. Basically, we are using some technique to define such types of the units by putting the other quantities for this unit. So here we are proceeding in this course of the class. We are proceeding for some advanced type of the steps. Previously, we have not discussed in detail about the types of the currents. Now we are discussing, in this class, we are discussing the types of the current in detail. So there are two types of the current. One is electronic current, and this type of the current, most of the time you have studied in the low grades as well. This is the current due to the electrons. Basically, the current is due to the flow of charges which flow. They are basically electrons. The charges which are not flowing, which are immobile, that are positive holes, and we will discuss in our next classes in detail. But here is electronic current, and in 17th century and later on, the direction of the current was considered with the positive charges, and it is still in use. But in reality, the charges which are flowing, that are flowing from negative terminal to the positive terminal of the battery, and this is called electronic current. Now the next one is conventional current. What the conventional current is? The current flows from positive terminal uh, to the negative terminal of the battery. In reality, if you look at the number of electrons which are moving from negative terminal to the positive terminal, they are in the same number, which the positive are increasing from negative to the positive. So that's why the direction of the conventional current is always taken from positive to negative. But the direction of the current, in reality, the electronic current is from negative terminal to the positive terminal. So here it is. These are the two types of the currents which we will study during this course of chapter in detail, where the conventional current is and how it is represented, how it is calculated and when it is applied. So here it is. If you look at, we are moving towards another conventional current terminal to the negative terminal. So discuss the flow of the steady current through a conductor. We are asked with another question. Discuss the flow of the steady current through the conductor. Here is the answer. What the steady current is. First of all, let's understand about the steady current, and then we will go up to the conductor and we will discuss in detail. So this is the definition: the continuous and the steady constant, and the constant flow of the electron in a circuit is called a steady current. This is the concept of a steady current. The continuous and the constant flow of the free electron in a circuit is called a steady current, and we will discuss while considering this diagram. We will discuss in detail what happens. For a steady current to be maintained in a circuit of a battery, a potential difference V is connected. The charges then starts to flow at constant rate. When this battery is connected with the circuit, then the charges starts to flow with a constant rate, and these charges are flowing along this direction, that is from negative terminal and then towards the positive terminal, and then they come back to the battery. So here is the direction of the current, electronic current. So the flow of the electronic current can be easily explained by a reference figure, and I am explaining with the help of this figure. The conductor has a large number of free electrons. Already we have discussed where the free electrons are. When the electric field or a voltage is applied, then the free electrons, being negatively charged, will start moving towards the positive terminal. Here it is. Negative electrons being free, getting some certain amount of energy, electrical energy from the battery, from the terminal. They use this amount of energy to overcome the repulsive forces and against the electric field. Look, this is the direction of the electric field. Electric field direction is from left to right. The electrons are moving from right to left. So that's why they have to do some work against the electrostatic force, against the electric field. So amount of energy is required, and this amount of energy is supplied from the battery. Following points must be noticed. Here it is. The actual direction of the current is in a conductor is due to a battery is from negative terminal potential of the battery of the cell. However, the prior electron theory, it was assumed that the current flows from positive terminal to the negative terminal of the cell via the circuit. This convention is so firmly established that it is still in use. This assumed direction of the current is called conventional current. Basically, it is assumed type of the direction of the current. So in the sense is that the same number of electrons are moving from negative to the positive, and the same number of positive holes will be created to the other side then. So that's why it is established, and it is assumed that the flow of the current is from positive to negative. And consider when we discuss the same whenever we are discussing some circuits or the circuit problem. So here are some types of important points which you have to remember. Number one is we have to see what are the conductors, then we have to see what are the insulators, and then we will see what are the semiconductors. We will discuss three types of materials now. The substances which have large number of free electrons. So free electrons will permit electric current to flow easily. Such substances are called conductors. For free copper, zinc, silver, aluminum. These are some of the most important examples to understand the conductors. Basically, conductors are those types of the substances which are the free electrons, and when we connect that type of the substance with the source of the battery or energy, then the charges starts flowing from one end to another end. So these types of the substances are called conductors. So if you look at the other one, that is insulator, those substances which have no free electrons and do not permit electric current to flow easily, such substances are called insulators. For example, wood, glass, and plastic. Nowadays, the topmost research which is carried out is under the process in the lab. So the people are researching, they are trying to get the reasons and solutions of passing the electric current through the insulators. So they are working on it, and hopefully, inshallah, hopefully they will get it done. So next is we have discussed two, that is the substances which are conductors having free electrons, the substances which don't have free electrons, and then semiconductors, they are class of the materials which have properties between conductors and insulators. Why? Because at normal temperature they are not, they are insulators, and with the increase of the temperature they becomes conductors. So that's why we will discuss in semiconductors in detail during our next classes. But let's clear it once more that these are the germanium, silicon. Most of the time they belong to group 4, where they have equal number of electrons in their valence shell, as the number of the electrons required to complete are the same, that is 4 more. So that's why they are considered in semiconductors, and semiconductors are playing very much important role in construction of semiconductor devices and number of other devices which are working and supporting the human life and other life benefits, benefiting our life. They are purely constructed on the basis of semiconductor devices. So thousands of applications are linked with the semiconductors, and we will discuss what are the types of the semiconductors and why they show such types of the behavior whenever sometimes at normal temperature they are not conducting, and when the temperature is increased they becomes conductor. The same happens in case of conductors, which is reverse of the semiconductor. In case of the conductors, the conductivity of the substance decreases, and we will discuss in this chapter in detail why it decreases. Because the vibrations of the atoms, collisions of the electrons with themselves, with the atoms increases, and more the vibration, more will be the reduce, slow down process of the electrons. And so that's why the resistance of the conductor will increase with the increase of the temperature. In metals, free electrons are always electrons. In semiconductors, conduction is partially due to electrons and vacancy, that is holes. Electrons and holes are playing some important role for the conduction in case of semiconductors, but in case of gases and electrolytes, moving charges have negative uh, and the positive. If you look at electrolyte, one of the substance which is the most common, that is salt, NaCl. This is a sodium chloride. In case of sodium chloride, whenever it is compound is formed, it is formed with the complete transfer of electron from sodium atom to the chlorine. Before transfer of the electron, both positive and negative charges are the same. That is, sodium is neutral. At the same time, chlorine is also neutral because number of positive and negative are same. But to fulfill the condition of to complete or obey the octet rule, one, that is sodium, transfers its electron and get the deficiency of the electron. Now it's positive like sodium ion. At the same time, the chlorine is getting excess of electron by one. So the negative charge will increase after getting one more electron. So these positive and negative charges combines to form a compound, and that type of the compound is called inorganic compound. When that type of the compound is say dissolved in water, it again produces positive and negative ions, that like sodium plus and chlorine minus ions. These ions are basically responsible to conduct the electric current. So in case of electrolytes, the conduction takes place due to positive and negative charges. So here it is. So up to this point, we have discussed in detail what is the current, what's the unit of the current, and how will you define the unit of the current. Here we were, and we have discussed the types of the current. Then we came up to another question, that is how the steady current is, definition, explanation, and we have discussed some most important point where the direction of the current will be. Then we have discussed about types of the substances. What are the types of the substances? Some are called conductors, some insulators, and some are semiconductors. And what's the importance for these types of substances? We will discuss in detail. Next is you have seen that conduction takes place due to electrons, positive and negative charges, ions, and at the same time due to positive and the negative electrons and holes. It happens in case of semiconductors, but in case of metals, it is due to electrons. But in case of electrolytes, it's positive, negative ions. And with this, I thank you very much for your attention.